Hi, this is Hadi. In this series of videos, I am going to talk about the gradient as an important parameter of hauler roads, especially in open-cut mines. For other topics and discussions about the mining industry, as well as tutorials, tips, and tricks in software packages, you can follow me on LinkedIn or by subscribing to my YouTube channel. I see many mining engineers wondering about what is the current gradient. Also, in many cases, you may come to a situation that this is you to evaluate your or others' pit design. One of the places where most debates are focused is the ramping system, but I see some engineers neglect or forget to validate and audit the credibility of a design based on its gradability. Here, I will introduce some of the best references for your own study in further details. Also, the methods and solutions to validate a ramp or road design. So I found it worthy to show some examples and tools to analyze the gradient of ramp and roads in a mine design. Whether you are a mining consultant, a mining planner, or operations engineer, I wish this video would be beneficial to your needs. In this video, we will review basics and concepts regarding gradient and introduce some of the software packages in this regard. In this picture, you see the forces acting on a moving loaded truck. What is generally referred to as the road gradient is the uphill or downhill slope. This angle can be measured in percent, degrees, or ratio like 1 in 10. But there are other gradients effective in the truck's pathway: crossfall slope in these two pictures and super elevation slope. The crossfall slope is the slope at the right angle of the route's horizontal alignment. It can be one side or, like this image, two-side crossfall. As many references suggest, this crossfall slope can vary between 1 to 4%. Superelevation is another gradient element you may encounter in a road design or need to implement it to your design. Superelevation is the lateral slope of the horizontal alignment to compensate the centrifugal force at the corners and curves. Although it is somehow similar to the crossfall slope, but superelevation is dedicated only to the curves and horizontal alignments. Original equipment manufacturers, or simply OEMs, provide some diagrams in the catalog of dump truck as a reference about how their machine works in response to the gradability of road and the payload. These performance curves are different for a truck when it is propulsioning uphill, that is called rim pull, and when it is braking, that is called retarding. Here you see a rim pull curve for Komatsu HD605 truck. This format is a generalized format which you see in the catalog of other OEMs models. By this diagram, one can predict the speed of a truck that can travel based on this payload and the gradability of the road. The left axis is the force produced by the machine in kilogram or pound. For example, if you want to find the traveling speed of this truck, if it is loaded to a gross weight of 110 tons, starting from point A, follow down to find one of these oblique lines which represents the gradability of your road and ramp. The total resistance, total gradability, should be taken into consideration, that is the sum of slope grade and the rolling resistance. The rolling resistance is the function of tire and road surface, which is measured in percent as well. From the intersecting point, that is point B, continue to the left horizontally to meet the related gear shift of this machine, which can produce this force to travel under this gross weight on this total resistance slope, that is 12%. This point, named C, helps you to find the final answer by going down to the speed axis, and in this case the truck can travel by about 12 kilometers per hour. There are many points and considerations about what these gradient elements must be based on the safety regulations, OEMs, and industry's common practices. These are addressed sufficiently in many references. One of the old but gold books to the miners is this one, Open Pit Mine Planning and Design by Hasroli. This is a 2-volume book that you can find pit geometry including ramp grade in volume number 1, Fundamentals. Let's take a look on some of the rule of the thumbs that is suggested in this valuable book. It says that the gradient of the haulage road must be fairly steep to reduce the length of the road and the extra material needed to provide the road length. As you know, the length of the haul road, especially when it's passing through the benches of a pit, affects the amount of stripping ratio. So we want to increase the grade to reduce the length of the road and reduce the stripping ratio as well. This rule of thumb is suggesting that the practical maximum grade is considered to be 10%. On next pages, it adds more rules, suggesting that 8% is a preferable road grade. One may ask, what if we flatten the road grade below 8%? This book says that it's unbeneficial because lowering the grade below 8% will increase the stripping amount with no benefits in increasing the uphill haul speed. Although the uphill haul speed will increase, but the benefits of the increased speed, traveling speed, will be offset by the extra stripping volume. Now let's take a look on the next book, Mining Haul Roads, Theory and Practice by Roger J. Thompson. In this chapter, nearly all of the concepts related to vertical alignment of ramps, as well as many useful tips are provided. What is the rolling resistance, performance curves with examples, as well as the retard curves, braking curves, and finding the optimum grade. I want to draw your attention to this phrase saying that ideally the gradient should be a smooth, even grade over the length of the ramp, not a combination of various grades containing several grade breaks. In the next video, I will show you an example which has this problem and how to reveal it and make annotations to show these variations in different softwares. The next is a regulation act by the Australia's Queensland government for designing and construction of mine roads. Here again, some useful tips are provided as a general rule of thumb but I want to again draw your attention to this special phrase that is addressing how to consider the grades of ramps and roads at or near intersections, and it suggests that we must keep it as flat as possible. This is a guide rule when we are discussing about switchbacks, because we may have intersections at switchbacks, and to somehow switchbacks are the places, the spots, locations that the sight distance is limited. And at the end, I want to introduce this very handy and useful guideline from Caterpillar entitled Haul Road Design and Management by Peter Holman. Let's page through this very handy guideline. I just want you to show how plenty of information and tips are provided here. After this page, that's simply saying about crossfall, as I showed you earlier in that slide. This is a one-side crossfall, and it suggests that on grades, minimal crossfall is required, and it should be avoided unless rainfall is heavy in that mine. This simple statement will give you an idea that when you are assessing the credibility of the ramping system, when you are measuring 2 points on each sides of the roads against each other, the bearing and distance, there must be minimum crossfall slope. And again, just remember that it is different than super elevation. That's the lateral slope we may aim to in our design at curves, for example at switchbacks. Again, Cat Global is also recommending that the optimal grade is a smooth and constant grade, and the grade must not oscillate. The reasons looks very clear but are very fundamental and critical: minimizing transmission shifts, because every time that the slope is changed, the truck needs to gear up or gear down the shift, and this will cause fatigue in the mechanical and rotational parts of the transmission system. Maintain higher average speed, allow more constant braking for on returns, that is the retards performance of the machine, reducing slippage, that means the falling of rocks and loads from the body of the truck when it's changing changing the grade, and especially reducing fuel consumption. In our next video, when we are analyzing a mine design, a pit design, we will see that how this myth is being wrongly used when this design was being prepared to include a flat path, a flat profile, a flat length in the ramping system of pits, rather than those locations that we need a nearly flat connection of the bench entry, bench access to the ramp. That's flat sections that wrongly are assumed is needed to help the machine cool down and better perform, are actually the defective parts of the ramping system, and are influencing badly to the machine and haulage performance. Also, in this slide, there is another valuable statement. Basic indicator of optimal grade is cycle time. It will give you the idea how to find the optimal grade for a fleet of trucks. You saw that there are lots of variables that must be considered regarding the geometry of the haulage profiles, and one of the most challenging parameters is gradability. There are plenty of software packages in the market to deal with that. I group them in these two categories: graphical validations by GMPs, this is the abbreviation for General Mining Packages, and the second category is haulage calculation and simulation software solutions. All of the GMPs have the tools for inquiring and measuring the grade distance in different angles and between different points of a segment, or the points not lying on the same segment. But I'm covering these with 3 GMPs in my next video because I found them more handy and more common in the market. The first one is by the Maptech group, Vulcan. The next is DesviCAD, and the last is Jovia Serpac. In the second group, calculation and simulation solutions are grouped together, but I'd rather split the simulation solutions like this one, Haulage Sim, by the RPM group, into the third category because they are really different in functionality and application. Most of the tactical planning and scheduling packages, like Spry from the Macromine group and Mineshift from the Jovia group, do calculations of haulage. They will take the performance curves of the trucks and find the routes by block selection and through their sequencing algorithm, and calculate the cycle time for each block and the required TKM, ton kilometer, and such like KPIs. In the next video, we will use the tools in this group, GMPs, to get familiar with simple but handy functionality of each in graphical validation of gradient.